So this is the overall layout in the last floor of the building. Like you see here, we have the pumps in the basement. Again, we have the riser here. The riser is going above, and in the last floor we have the arrangement like this. Okay. So like you see here, I have marked the hydraulic area. In our calculation, we received total 13 sprinklers. So 5 in the first row, 5 in the second row, and 3 in the third row. So totally this is the hydraulic zone for our sprinkler. Okay, now I'm going to provide the node number one by one. Actually, node number is nothing but just an identification number to identify each point of the sprinklers or other points. So first I started from node number 1 in the last sprinkler, and before that 2, 3, 4, 5 and 6. Okay, so this till the 5 point we have the sprinkler in the hydraulic area. So 6th point also I consider, because the 6th point is serving to the sprinkler in the hydraulic area. So till here 6th I consider, but I didn't put the 7th here or here. I directly moved to the 7th here, because the reason is this area is not comes under hydraulic area. First, that is the reason. And here pipe size is 2 inch, here also 2 inch. Okay, so first it is not in the hydraulic area. Second thing, both this gap we have the same pipe size. So because of this two reason, I moved from node number 6 to 7 here. Okay, not in between. So like you see here, the same step I followed. Sprinkler 1, 2, 3, 4, 5 and 6. So till here we have the hydraulic area, na? And here the 7th point is above the riser nipple. Okay, because here the pipe size 50 mm, here also 50 mm, and it is not in the hydraulic zone. Okay, so here I put the node number as 7, and below the riser nipple the point is 8. Okay, so this line will go here also, na, to the right side also. So there will be a riser nipple here, and below the riser nipple I put the point number 8. So next one is after the 8, the point number 9 is in the cross main. So point number 10, again I went to this hydraulic area sprinkler 10, 11, 12, 13, 14 and 15 till this hydraulic area zone. So again I don't need this area, because this is not in the hydraulic area and the pipe size also same. So I put 16 here. Okay, so then 17 mean again this point 17, and I will explain why I put 18 instead of here, why I put 18 here, even though it comes under hydraulic area. I skipped this point. Okay, I'll tell you the reason also. And from here 19 I added here. Then after that it is not in the hydraulic area, no point, so we'll directly go to the pump last point till the last point. So I will tell you how to how you can add the node number here. So coming to the fire pump pressure point of view, the longest path for the fire pump is which is going like this. So it will go till this point. Okay, so the longest path of the pump is like this one only. But if you see here, this area and this area and whatever the sprinkler comes in this area, so these are the arrangement. We don't need to consider the pressure, because the fire pump will struggle to throw the water till the last point. So if the pump can throw the water till this sprinkler, that means the fire pump can easily throw the water till here and everywhere. Okay, so that is the reason, coming to pressure point of view for the fire pump, we have to consider the longest route only. So what are the fittings comes in the longest route, that fittings we need to consider for the pressure loss. And coming to hydraulic flow point of view, what are the things in the flow zone? For example, in our case the flow zone is like this. So what are the things in the flow zone that we need to consider? Okay, so this area we need to consider. So in this Excel, you can see here the start node I have given, end node I have given, and this point is a sprinkler point and no sprinkler point. The sprinkler mean SP, no sprinkler mean NSP. This is for our identification, and we have given the flow here, and the flow I will tell you how I got the flow, and pipe size and the pipe length, and this is the fittings equivalent length, pressure loss, total pressure drop and required pressure. Okay, so now we need to find out the pressure and the flow. Okay, required to start the calculation. So in our calculation, if you see here, this is 3 meter for the sprinkler and this is also 3.6 meter. So we have to start from here. So 3 meter mean, if you convert this one to feet, it will be 9.84. So similar way, if it is 3.6 meter mean 3.6 into 3.28, it will be 11.808. Okay, if you round off it, it will be 11.821. Okay, so I put the same value 11.81 into 9.84. So total the area coverage of one sprinkler is 116.21. So the same I applied here 116.21, and I multiplied with the density. For the ordinary SR1, the density is 0.15 GPM per feet square. So I multiplied with that answer. Q is equal to D into A. D means the density. A means the area of the coverage of a single sprinkler. Okay, so here you are getting 17.43 GPM, round off to 18 GPM. So that means from one sprinkler the flow is 18 GPM. So we know the formula Q is equal to K into root of P. So in our case, the K factor for the sprinkler is 5.6. So in the next video, I will explain how to find out the K factor for the different sprinklers and different application. And for time being, consider K factor 5.6 we consider for this application. So the P is equal to, you can see from this formula, I can make P is equal to Q by K into square. Okay. So the Q, we know that 18 GPM, and the K we know 5.6. The square of both the answer is 324 by 31.36, and it will be 10.33 psi. So as per NFPA 13, the minimum operating pressure of any sprinkler shall be 7 psi. So we have to make sure our answer is more than this value. So here we got 10.33 psi, which is more than the 7 psi. So now we got the flow, we got the pressure, then we can start the calculation. So in our case, if you see here, node number 1 to 2, we have 3 meter gap. So 3 meter means 3 into 3.28, you can make 9.84 feet, and it is 25 mm. And we have one elbow here, and here we have one T here. Okay. So when you go for node number 1 to 2, you can consider this T, this elbow also. Otherwise 2 to 3, if you are adding this T also, it's not an issue. You have to add the T either 1 to 2 or 2 3. But you have to consider the T. Okay, that's the important thing. So now let's do the calculation. So first 1 to 2, if you see here 1 to 2 sprinkler pipe, and 18 GPM we just now we got from the calculation 18 GPM and 10.33 psi. So the 18 GPM I consider here, and from node number 1 to 2 both is 18 GPM. Okay, and here pipe size is 1 inch. Same from here you can see 1 to 2 the node size, the pipe size is 1 inch 25 mm, and coming to the pipe length it is 3